Okay, we're now looking at the stats paper, and we're going to go question by question to see how we go. So this is topic 7. It's worth about 35 marks in the exam. So let's have a look at the first one. Kangaroo Island Farm supplies eggs to supermarkets in South Australia. Wanted to conduct a test to investigate the weight of its large eggs. The weights were found to be normally distributed, so the average weight or the mean weight was 60 grams, and the standard deviation was 8. So we've got these two bits of information. The first part, complete a normal distribution model based on the given above. So make sure that you put a title on your graph, which is weight of eggs. Make sure you tell us that it's grams down the bottom here, and then across the bottom is your mean, and it goes up in the standard deviation. So 60, then 68, 76. I'm just adding 8 each time on the way up, and conversely on the way down we then take 8 on the way down. You can then put in your percentages, so 34%, 13.5, 2.5. I would possibly make sure that you remember them, because they're handy for all the calculations and things later on. So there you got it. You've got to label it like that. Make sure you have a title on the top, and it's all good. The second part of the question says, on the distribution curve in part A, shade the area that you represent the percentage of eggs that you expect to weigh less than 44 grams. So we're looking at less than 44 grams, which is in this section here. So you just have to highlight that. Now obviously you'd highlight it a bit better than I have, but we just do it that way. So you're looking at that section down, so the 44 down, the last 2.5%. If 2,000 of the eggs are tested, how many would you expect to weigh less than the 44 grams? So you can either just go 2.5% times by the 2,000, or you can use your calculator with the lower, upper and standard deviation and the mean. So if you can remember how that goes, you go into stats, then you go into distributions, normal, which is F1, NCD, and you come with the lower and upper. The lower is the lower limit, so for us that's going to be 0. The upper limit is going to be 44, because we want anything below that. Your standard deviation is 8, and the mean is 60. And then you just come down and go execute, and it will come up with 0.0227. So notice how it's nearly 2.5, but this is more accurate than the graph, because we're kind of averaging a bit in the graph. So then to work out how many eggs, because it says how many eggs, then you get the turn it into a percentage, times by, which should be 0 there, 2,000 equals 50 eggs. So the same as if you did 2.5% times 2,000, that would be 0.025 times your 2,000, which would then give you your 50 eggs as well. Okay, so you can either use a calculator or use the off the graph there. The next part of the question says, what percentage of the eggs would you expect to weigh more than 65 grams? So once again we're using the lower and the upper bit. Now just a bit of a trick is here, you've got your lower is 65, so they're going at 65 or above, so your upper you put as a very big number, your standard deviation is still 8 and your mean is still 60. Enter that into your calculator, so you just go back into this bit here, go up and change your upper to 60, your lower to 65, and your upper to anything with a whole lot of zeros on it, doesn't really matter. Then come down and go execute, and it works it out as 0.265 or 26.59 or 26.6%. Okay, so ask for the percentage, so your answer here has to be in the percentage. The last part of the question, this is probably a bit more of your complex questions. Remember we said that it's routine and complex questions. One supermarket decided to sell the smallest 5% of eggs at a discounted price. What's the minimum weight of the eggs needed for the customers to get discounted price? Now, I think that should be maximum weight, because otherwise it doesn't make any sense. But anyway, let's go from there. Let's go and show you how it actually works out. So you've got to go to a different part of the calculator, because this is the inverse norm bit. Now the area is, you're looking at 5%, which has a decimal of 0.05. Okay, so your area is 0.05, because remembering that with your hill-shaped graph like this, you're coming from this end. Okay, so if you're looking at 5%, that's coming out to there. So your area is 0.05, your standard deviation is still 8, and 60 is your mean. So on your calculator, you've got to come back to distributions, normal, inverse normal, because now you've got the area. On these calculators, the tail is still on the left. Your area is 0.5, and it should pull through from you the standard deviation and the mean from the other questions. Come down, go execute, and it's 46.84 grams. So it says to you that the eggs, the maximum weight that will get to that will be 46.84 eggs. 46.84 grams, sorry. So just remember that's the inverse section on the calculator. Very important that you know how to do this, because it matches with the calculator, and it's that complexity that you need to have.